வணக்கம், குட் மார்னிங் எல்லாருக்கும். வணக்கங்க. இந்த செஷன் வந்து சாய் மணிவண்ணன் ஃப்ரம் சிகாகோ அவர் வந்து எடுக்க போறாரு. அது வந்து ஏபிஐ டிசைன், ஏபிஐ பேஸ்டு டிசைன் எப்படி பண்றது அப்படின்னு சொல்லிட்டு. ஸோ சாய், நீங்க வந்து இந்த கோர்ஸை பத்தி கொஞ்சம் டீட்டெயிலாக சொல்லிட்டு உங்களை பத்தியும் ஒரு அறிமுகம் பண்ணிட்டு ப்ளீஸ் கோ ஹெட். ஐ திங்க் வி கேன் கீப் இட் இன் இங்கிலீஷ். சாரி, ஐ எம் மிக்சிங் இன் தமிழ் அண்ட்
No worries, no worries. So today it's going to be primarily about APIs, and the first class will be primarily an introduction to APIs. Since different people are coming from different backgrounds, the first session we want to keep it really, really simple and fundamental, and make sure everybody gets the basic concepts around APIs. And if there's enough interest in the class, we will proceed on to like 2 or 3 more sessions, which will go a little bit more into API design in a little bit more detail. About myself, basically, I have a couple of decades experience in the IT industry. Primarily, I have my own company called confluence.com. And we primarily focus only on APIs and a little bit about on the hardware side also, by the infrastructure side, a little bit on OpenShift, Kubernetes, etc. But our core focus is basically API platforms. A couple of leading platforms within that is MuleSoft, Apigee. People may have heard about these names. Those are basically API platforms, which helps you host and manage APIs for enterprise, ideally enterprises, and also like small, medium enterprises. And these days, even small businesses are getting into it a little bit. On my side, I also, full disclosure, I also work for MuleSoft Professional Services as a solutions architect, contractually. Even though I have my own company, I work for them through contracts. So in a nutshell, that's what my background is. Let me jump into the course in a little bit, actually, at this point. So we're going to get started with APIs and what they're about and why everybody is talking about APIs a little bit. At its core, what API literally means is application programming interface. What it means is it's a set of functions that programmers can use to interact with an external system or a service. Typically, when you're talking about programming, right, it's our systems, you tend to think in your mind, it's an interaction between a user and a system. But with APIs, one thing you have to understand is it's between a system and a system. That's a key distinction that you have to keep in your mind that people tend to forget. And it gets to be much easier to understand it if you think about API as a system to system intermediary. So it's basically a software intermediary that enables two systems to talk to each other. So what it basically means is on one side, you have a service provider, right? And you have to, another system basically has to use some means to talk to that particular service provider's services, right? And that is via means of what is called an API. So on one side, you have the service provider, you have the interface, which is your API, and on the other side, you have a service consumer, multiple service consumers. And the guy in the middle is basically what basically an API literally means. So the concept is nothing new. If you think about how our day-to-day lives are constructed, right? You need electricity, which is a very, very basic service, right? And you have several service providers like ComEd, Amran, different kind of electricity providers on the other side, on one side. Now, they all agreed to a common interface, which is basically a socket, right? So all these guys are basically saying, I'm going to provide you this many hertz, this many volts, etc., as an interface. And that way, because there's a uniform interface, you can have multiple consumers exploiting that particular uniform interface, right? So essentially, this is your API. You can think of it this as your interface, this as your service provider, and these as your service consumers. Right. Now, what this nice thing about when you have a common interface is you have a layer of abstraction in the middle, right? So when everybody is providing 120 volts, 60 hertz, I can take my microwave and plug it in. When I'm in Chicago, I'll be using ComEd. When I'm in Missouri, I might be using Pacific Gas, for example, not Missouri, but Boston or whatever, right? So when you have a uniform interface, basically the service provider behind the screen can keep changing, right? And without any change to the service consumer, right? That's a very, very key concept in API design. Think of if you as a company, you're going to provide a set of services, right? And if you want to provide those services, multiple consumers should be able to use those services. That is one key element in terms of providing an API service. Also, today my API service may be using, like say for example, I want to store customer data, right? And I have a service for a CRM, customer relationship management system, and I may be using Oracle today uh, to store all the customer data as a service provider on the side, as an API provider. But then my cost has increased. Oracle has increased their licensing cost. Then I want to switch over to a different, more MySQL or like a cheaper open source SQL system, Postgres or whatever. When I change something behind the screen on my service side, it should not affect my consumer in any way, right? That is a key. If you have like 100 customers, because you are changing something behind the screen, uh, nothing should affect the customer, right? And that's a very, very key concept again in the API abstraction. If your interface is nice and clean, the service consumer will no way know behind the screen a bunch of changes are happening based upon your business considerations. For example, licensing is one such consideration. That is a key element in API service. One more thing is like, if you look at it, right, as a service provider, all these guys care as a service consumer is, I need to get electricity services when I plug in into a socket. That's all they care about. How that service is implemented, in what mechanism, they don't really care. For example, ComEd will use, regular electricity, right? Like this guy will use a windmill. ComEd might use a water-based electricity. Pacific Gas might use like nuclear power, right? So the implementation of that interface can be in any which mechanism. In software terms, right? Once I export the service, my implementation can be in Java, my implementation can be in C++, my implementation can be in C#. It doesn't matter. To the consumer, all of that is abstracted by providing an interface that is basically agnostic to the kind of implementation that happens behind the screen. And this way, right, there is very, very loose coupling between the service consumer and the service provider. I'm abstracted by that interface, and I have no idea behind the screen if they're using C++ or Java or C#, or it doesn't really matter. All I am care about, what is it that I need? Can you provide me that particular information and data? And how you do it, I don't really care as a service consumer. Any questions at this point? Okay, so I'll keep moving forward. So as a, once again. So it's a very simple example, right? Everybody knows about Google and MapQuest, right? And say, for example, and both of them, they can introduce an API called a mapping API, right? And you can have multiple applications like a mobile app, a web app, etc., using those APIs. Another nice thing about web APIs is it gives you some kind of freedom in terms of device. I can use mobile, I can use web, I can use like MQTT, different kinds of interfaces, and I'm able to produce a single interface, which will later come down called the REST, right? REST API, which will help you basically use multiple devices to access the same API. So in this particular example, right, your provider is basically a service provider, which is providing a mapping service, is basically Google as one example, and MapQuest another example. And on your consumer side, you have, say, for example, find me the closest store. When you say find me the closest store, you need your current coordinates, right? And you need a list of all the store information. And you would send that information, and Google will have its own directory service that will help you find that, the closest location of a store, and etc. Right. So at the same time, from an application, for example, if you are an application that you're selling on Android or iPhone or whatever, right? and you would need that feature implemented in your app, then I would not build. It'll take a tremendous amount of time building all this stuff, right? Finding the coordinates, finding the map information, etc., etc. So you would reuse whatever is already existing from service providers. Rather than reinventing the wheel and implementing all those features, you would want to use existing APIs and leverage those existing APIs to basically fulfill your need, right? So if you are a guy that just finds, a set of closest retail stores, I'm not going to build my mapping API. I will just reuse whatever mapping API provided by Google or MapQuest. And sometimes you have to pay them a royalty, uh, right, based upon the usage. For example, right, if you are a very popular app, you're going to make 2 million calls to a Google API, then that service is not going to be free. Like if you're doing it for 500 times a day, it'll probably be free. But if somebody is hitting you 1 million times, you would have to pay a kind of a royalty to Google, right? But it'll still work out because if somebody is calling you 1 million times, you're probably making some kind of money over there. Otherwise, they would be calling you. And so it's worth paying Google a portion of that money so that you don't have to maintain, upgrade, any kind of changes. You don't have to adjust to everything. All those kind of services are basically outsourced to a service provider who specializes in what they do, so that you, as a web application or a mobile application provider, you can focus what you do best, which is basically finding the closest doctor or finding the closest retailer without having to worry about the implementation features of the mapping information, which you are outsourcing to an API provider. So in this case, right, even though you are the mobile app provider, you will take the role of a consumer to that particular API service provider. And like that, you can interact with for doing one mobile app, you might have to interact with 10 different API providers. Um, Say, for example, it's a realtor app, basically, right? And you're finding a list of closest houses to one person's location to show them those houses of interest. So at that point, I will call the Google API to find all the, within this particular zip code, what are all the different coordinates and available, and what are the addresses that map to it. And I might use Zillow for the houses that fall under that particular zip code within 10 miles. Zillow, everybody has heard about Zillow, which is a real estate company, right? And they have something called a Z estimate, which is basically their estimate on the pricing of a particular house. So as a service provider, right, which I mean, as a mobile app developer, right, like who has a mobile app that gives you like realtor.com, I will use Google API to find all the coordinates and to restrict the number of houses you show to your consumer. And for the Z estimate, I'll make another call to Zillow to find what the Z estimate of that particular house is. So basically, you're interacting with the mapping API as well as another Zillow app for the Z estimate API, and consolidating all that information and providing it to your consumers. So that's where APIs become very, very powerful. You're basically interacting with a bunch of third-party APIs and doing what you want to do as an app. Like 10 years back, 15 years back, what you would have to do is you would have to code all the stuff on your own. And every mobile app developer was doing that, and becomes very, very hard because your core functionality is to serve up the consumer's needs in terms of user experience, giving them more information about housing, schooling, etc., etc. So there's a variety of concerns that you have to solve, and you don't want to get into the details of mappings and coordinates and how to do like a statistical function to derive the Z estimate. You leave that up to the service provider who's expert at what they do, and then focus on what you really want to do, which is basically give a good user experience, very useful information over a variety of information, to the end user. So the word API typically is kind of a little bit of it's overused and abused a little bit. But traditionally, what we mean by the word API is literally people used to use Java API, JMS API, so on and so forth, right? That API is from a programming sense. If you create like a Java application to connect to a database, you would use something called JDBC, Java Database Connectivity API. To connect to a queue system, you would use something called JMS, a Java Messaging Service API. Similarly, Windows applications will use some kind of Windows API, and those APIs will be used to, like a draw to store to file API that the Windows system basically exposes so that you can code applications that work on a Windows system. Now, those are all non-web APIs. These days, when we say web APIs, when we say APIs, it almost literally means web APIs. And web APIs essentially are basically two kinds. One is people may have heard about SOAP, SOAP, which is a web API, a simple object access protocol. This was originally created so that multiple businesses wanted to talk to each other, right? And there was no standard way of talking to each other. Business A is talking to business B. There's no defined mechanism or standards to talk to each other. That's where SOAP came into picture. SOAP primarily works over XML, and XML is basically a kind of a language free, right? You define everything in attributes and elements, and it's not tied to a particular program like C++ or Java or Python or any particular language. So your consumer and your provider did not have to implement the same language. I will be using C++. They will be the service provider will be using Java, and because there was a SOAP interface that talks XML, I need to talk XML here. The provider will talk XML, and you can interchange all that information via a SOAP interface. Right? So that was originally like for the last 15 years, SOAP as a protocol and as a means of communication between two businesses became very, very popular. But on the and SOAP is one of the web APIs, and it was quite popular for a while. But the problem is, I need to implement some SOAP specific software, and I have to do some kind of like coding per SOAP standards in order to achieve that function. So there was a little bit of an overhead on the consumer side to access a particular SOAP service exposed by a service provider. And on top of it, XML is extremely verbose. For example, if I have to describe, a name and an address of a person, I will have a person tag and then a closing tag for a /person and the person name, and each of the attributes will have a tag, like name, address, SSN. There'll be an opening tag and closing tag. So in terms of byte size that you're sending from the consumer to the provider, right? You're going over the internet. All the web APIs are going over the internet, right? Through HTTP call. And when you're doing that, the amount of information I have to send over the wire is extremely verbose. Your byte size is quite a bit, which was okay. When you're doing business to business, right? It was quite okay. It was manageable. But in these days where social media has taken over and the amount of consumer to business B2C has completely taken over the last 15 years, especially since Facebook and Twitter and everything has come in, right? The B2C market has exploded, right? End of the day. So that's why you're seeing Netflix and Amazon, all these companies, it's all consumer focused. So it's all B2C. And when you're talking about, like 100 kilobytes, over 5 million users, that becomes a tremendous amount of volume on the server side, right? That the server needs to handle back and forth across the wire. And that can make your servers extremely slow because of the sheer volume of it. And that's why SOAP slowly gave into what is called REST API, which we'll get to. So REST is basically another form of web API, which has basically overtaken SOAP currently. Okay, so both Web API and REST API as well as SOAP API, they work over a simple HTTP protocol. People, almost everybody will be familiar with HTTP protocol, which is when you open a browser and type http://xyz.com, you're using the HTTP protocol at that point, which is very, very, very popular and ubiquitously used. So from a REST API standpoint, uh, REST basically tries to keep things simple, and it leverages the HTTP protocol fully. Okay, and we will see how as we go a little bit deeper into the class. So at a very, very, very high level, right? You have a client, you send a HTTP request, and you get a HTTP response, right? And there's a server that serves this up on the other side. Your client is it's either a browser or a software program that sends the request and gets a response back. So, like I said, the very, very fundamental of HTTP, of REST API is the HTTP protocol. So what is the HTTP protocol? One, you have what is called the URL, which is a uniform resource locator. So it helps identify a particular resource. We'll get into what it is a little bit further. You have a URL, you have a method, which is like typically you do a get method, right? When you type in www.google.com and press enter, you basically call the www.google.com is your URL. Uh, the method in that particular case is a get method. And when you send that information, when you press enter and send that information, there is also a list of headers that goes across. For example, there can be a MIME type, there can be a content type, there'll be like what kind of browser it is. All this information are being sent across as part of a headers when it travels across using the HTTP protocol. That helps determine on the server side what kind of response has to be kind of massaged and sent back to the caller. So the list of headers will basically carry what is called metadata. What you're sending to www.google.com is basically information. For example, if you go to mail.google.com, right, and you put in your username and password. So the data is the username and the password. The URL is mail.google.com. The method is a get, and the headers will be metadata about the data. The data is being your username and password is the data you're sending. Metadata is like which browser you send it from, what is the version, so on and so forth, right? And body is again like, what your body will contain the data. In this case, the username and password will go in as key value pairs, for example, right? Like username, what your actual value is, password, what the value is. That will go in the body. So these are the key, and it's very simple, but it's extremely important to understand. This is what the HTTP protocol entails. There's a URL, there's a method, there's headers, and a body at a very, very simple level. Now, from a pure HTTP standpoint, right? A URL is a unique address for a thing. To put it very simply, right? Say, for example, you as a company want to create you have like 5 customers, for example. You are a company, you have 5 customers. So you have different entities, right, to maintain that system. I will have what is called an account. I'll have leads. I will have contacts, right? For example, leads are something that can potentially turn into a customer. When it becomes a customer, I will call that an account, right? And within an account, I will have different contacts. Who's the sales rep there, who's the customer service manager there. All those will be contacts. So, for example, so these are 3 different entities I would need to maintain as a company on my side, and each of those entities, if you think about it, it's a noun, right? Account, leads, contacts, all those is a noun. So the URL is a unique address to get to that particular entity. So for my company, right? So for example, I'll have mycompany.com/accounts. So if you go to a URL, open a browser and say www.mycompany.com/accounts, that should give you a list of all the accounts at that point, right? But that URL is a specifier to get to that particular account, okay? And that is going to be supported by a set of methods, which you will later see. And what which things get addresses is entirely up to the business running the server. So in my case, I'm providing a CRM solution, right? So which things, those things will be accounts, leads, and contacts to start with, right? So the URL can basically serve up when I call slash accounts, right? It can serve up anything. It can serve an image, video, web page, whatever. In my case, it will send all the as a web page, the list of all the account information. Okay. And APIs extend this idea a little bit further to include nouns like customers, products, which is what we'll be basically doing as a REST API. And URL becomes the easy way for the client to tell which server the thing wants to integrate with. Some people will be interested in seeing the lead information. Some people will be interested in seeing the account information. And if you're a member, only then you can see the account information, right? So how do I differentiate the different calls? I will do it through the URL. If I have slash accounts, only the members who are customers can see that. Slash leads, only the sales rep can see the slash leads, so on and so forth. Okay. And within the API terminology, these nouns or the things, they will be called very simply called they. That's what when you say a resource, that's what we mean by that. Okay. So the first what we just saw is basically the part one of this, which is what is a URL. Okay. And the second part is basically what's a method. Now, if you think of it from a simple operational standpoint, right? Like I said, you have multiple entities, account, leads, say, contacts, etc. And I want to save this information of one particular contact. Name is Sai, phone number, address, so on and so forth. So ultimately, when I save that information into my system, there's typically four things I would do. It's what in database terminology you call this as CRUD operations, right? CRUD, create, read, update, and delete, right? If you think about it on any particular entity, these CRUD operations is what I typically do, which is again create, read, update, and delete. I might want to create an account, I want to update an account, I want to delete an account, I want to read an account. This is typically what I always do. Now, inherently, HTTP protocol already supports this CRUD methods by what it already exposes as part of its protocol. For example, it has these four methods. Get, basically, it'll ask the server to retrieve a resource. So this is basically the read function in CRUD. Post is meant to ask the server to create a new resource. So whenever you want to create a new account, you would use a post method. When you want to read an existing account, you would want to use the get method. So the post is equivalent to create. In the CRUD operation, this is the C part, right? And put is basically ask the server to update an existing resource. There is also something called patch, but I don't want to get into the nitty-gritty of that. The put method is basically, you can think of it like the update on a particular server. If you want to, if an account already exists in your company and somebody changed their phone number, right? You would expose a put method to them by which they can send their information so that I can update their phone number on my database behind the screens. And the fourth one is a delete, which is basically ask the servers to delete a resource. In this case, like I said, when we say resource, it's the noun, it's the entity. People coming from a database background, you have an entity relationship, right? Those entities are basically very closely mapped. You can map it to a resource. That's what it is. And the CRUD operations you do on a SQL, basically, right? You can equate it to one of these methods over here at a very high level. Okay. So REST borrows, when I say borrows, it inherently has all this stuff inside it. And that's why, and it's very easy. There's nothing to install. Anybody with a browser and anybody who knows the basic HTTP protocol can exploit the functionality, and you design your systems to use that as your interface to provide all the functionality that you intend to provide. Okay, as opposed to implementing a software on their side to do the work that they want. Okay, and that's why REST API as such became very popular, because there's nothing to install. It exploits a protocol that already exists today and everybody is familiar with and can easily understand. And that's why REST API became extremely popular. Okay. So what we're going to see is basically a quickly example of a method. Give me 1 second. Okay. Right. In this example, right, say you're basically Pizza Hut or something, and you want a consumer, rather from a mobile app, a consumer wants to use a mobile app, which is the Pizza Hut app, to basically order pizzas, right? So when they place in this key, one thing to understand is the noun in this case is basically the order, right? The order that you take over the internet is basically your noun. Okay. So within the order, there's four functions, right? You create an order, you can update an order, you can find the status on order, which is equivalent to a read, and you can delete, you can cancel an order. So all those fall under the CRUD operations, which is like create, read, update, and delete. And, and you have to implement the HTTP equivalent of that in order to achieve your functionality. So when I use a mobile app and place an order, for a pizza, then for the placing the order, you're basically creating an order in that particular place. So you would use the post method in that particular case, right? And when you do a post, the post will have a body which will contain the details of your order. Okay, we will see what they are a little bit further. And then suddenly after you created your order, right, you realize, okay, I placed the wrong crust. So I, instead of a thin crust, I want like like a thick crust. So you would need to do an update to your current order. So that information has to go via a put request. Okay. And then while you're waiting for an order, you want to see what is the status. So in that case, to the server side, you will send a bunch of GET requests to find what the status is. And then, after you waited for 1 hour, you got pissed off and basically you want to cancel that order, right? So in that case, you would go ahead and delete your request. So this post, put, get, and delete are basically server-side functionality that you're exposing via REST API. And you have a mobile app, the Pizza mobile app, calling those server-side functionality via a REST API that exposes the order API, and you do 4 different operations on those order APIs. Okay, this is very, very simple, where I can, the entire ordering of a pizza, you are managing via REST API that exposes four methods on a particular resource called order. Okay. Like I said, so we saw what a URL is, we saw what methods are, and the third one is basically what a header is, right? The header, like I said, provides metadata information about a particular request. For example, you can capture the time. This has nothing to do with, see, when I send information about pizza, right, I want a thin crust pizza, I want like this kind of toppings, and that's all I want to send. I want to type only those kind of information, right? I don't want to tell, okay, I'm sending it at this time, correct? Like at 12 p.m. That time is very important from a server side. As a service, right? I'm a pizza provider. Within 10 minutes, if I don't provide that particular pizza to you, that pizza is free. So the time is very, very important as a service provider. If I am Pizza Hut, it's very important to me. But I don't want the user of the system to tell me to enter that time, right? So that request should have that information, but it should not be part of information that the user have to send in, right? So those kind of useful information for the service side is sent via the headers. Okay, and that's why we are saying those are all basically metadata about each request. 2 different requests sent at 2 different times will have different times captured in there, right? And also, as part of the header, the client can send user agent information. Whether it's a mobile app, whether it's a web browser on the computer, you can find those things out. And that's kind of also important because when I send the response back, whether you're a mobile app or you're a web via computer, laptop, or browser, right? I can possibly send you 2 different styles of response. I might make my response to a mobile very concise, very short, And for a web app, it can be a little bit more elongated actually. So based on what, and that kind of information again will be carried via the header. You don't want the user to send that information, but the system will be smart enough to figure that out and send it via the header for each particular request going in via HTTP. Okay, and that way the server understands what type and format is that and respond with two different kinds of response for the same request, depending whether you're mobile or a PC or something. Okay, so we saw what a URL is, we saw what a method is, and we saw what a header is. And now the key part is the body. The body is where the client sends the information of what relevant to that particular function. In this particular case, we are ordering a pizza. So in that body, we'll be sending what kind of crust, what kind of toppings, etc., that you want as part of your order, actually. So yeah. So ultimately, right, this URL, method, headers, and body, and together they form the complete HTTP request. Okay, in this case, we are requesting, we are basically ordering a pizza. Order becomes here now. URL is www.pizzahut.com/order, right, and then you do a post for creating an order. In the body, I will send whether it's thin crust, etc. In the header, I will send what kind of, whether I'm a mobile app and the time, etc. And because I'm creating an order, that will be a post for the first call. Okay, so this is your structure basically. URL, method is post, headers is user agent, time, etc. Body is the data. Okay, so on the other side, on the service provider side, right, what you send back is basically a HTTP response. So once you receive the request, right, I received an order for a pizza. So I got to go and hand that over order to a particular person who initiates the clock and starts the preparing that particular order. And on your response back, I will say, okay, the order is in progress at this point, or something like that, right? You'll send back a response. When you hit create order, you can send back a response. Thank you for order. Here's your order number 1234, right? A second person comes and creates an order. Again, you tell them thank you for order. Here's your order 4567, right? So you gave them an order number that they can then go back and look up and find what is the status of their particular order is. Okay, and in your response, the key thing is there's something called a status code in your response. If it's something that was successful, you will typically send back a 200. We will see that in the later class. And if it's an error that came from the client side, it's something that I cannot understand. You send me a request, I cannot understand your request, then we would send back errors in the format 400. Like 4xx, whether it's 404, we'll go to different things. 401, that's an authorization request error, so on and so forth. Anything 4xx is basically a client's error. Now, if I received your order, there's nothing wrong with what you sent me, and I'm unable to process your order because my downstream system is down, my database is down, my ordering system is down, right? Then it's a server-side error. Those errors responses will go as 5xx. A 501, 503, so on and so forth. We'll get to those response codes later. Okay, so 4xx is typically a client-side error. 5xx is basically a server-side error. Okay, and if it's successful, you would basically send back a 200 as part of your status code. Okay, and your response can contain headers. We will get to this a little bit later. And in your body, like I said, you will send back your order was received successfully, and you may send back an order ID so that that particular person can track. Okay. At the bottom of the screen, you would see like I don't know how to get. Sorry about that. You would see like, no, that's okay, relevant. Okay. So at a very, very high level, you have a HTTP request and a HTTP response. The request has URL, method, headers, and data. And response has very, very importantly a status code, a 200, 400, or 500. And it will send back a list of headers and also a body containing the information about your particular order in this particular example. So as an exercise, right, for you guys to get familiar, you can do this later. I will share this presentation with Aru, who will then publish it later. But this is a very mock example. So if you go to this particular site, you can basically send a GET request. Now, one important thing is a GET request is basically you're reading something off of the server. So a GET request, there is no body per se, right? If I'm going to just www.google.com, I just want to see the homepage of google.com. That's all I am. So I don't have to send any information across, right? So those are basically read functions. So for read functions, you will not have any body associated with it, right? And so you can try to see what happens when you send a GET request without anybody. If you send a GET request with somebody, you can play around. I want you guys to also try it and understand what the difference is. And you can send a post, which is to create a particular thing. You can send a put request, which is basically to update something. And you can send a delete to delete something. Again, if you think about it, right, even when if I'm deleting an account, um, I don't need anybody to go along with it. I don't need any instructions. All I want to do is delete an account, delete a contact, delete. There's no, I just need to give an ID to it. I don't need to send anybody. And we will see why later. So I want to pause here a little bit. And how are we doing in terms of time, Maru? Like,
It's a 9:50, Sai. Close to 9:50.
right.
How many slides you got? How many more you got?
Let me see. I'm in slide. I'm probably 70% through.
Okay, I think we can finish it off.
Is everybody okay with that? I can go a little faster, and I can share, and it's up to you guys. What do you guys think?
Yeah, I think everybody maybe little familiar. I am not from uh, developer per se, but even I can understand this a little bit.
That's the
So
intent, actually. So we want to
yeah,
make sure everybody understands. So
yeah, I think I can go and finish it today.
okay, sounds good. So let's get to the design part. Say if I'm a service provider like a Pizza Hut, right? And I want to create multiple people to basically order pizzas through a mobile app, right? Say for example, you can have a Beyond Menu or Uber or whatever. They should be able to place an order for orders coming to them also, right? So they in turn will be calling your APIs to implement that particular functionality, right? Which is basically on ordering Pizza Hut will have its own app, but it'll also and its own app will use the REST API service that it exposes, and it'll also have third-party apps like Uber Food or whatever, Uber Eats, and anything else that will basically call the REST APIs to place an order, for example. So you have service consumer, which is literally the user. You have a system, right, which is a service provider, and you'll be exposing the APIs. I'm missing one thing over here, which is basically the mobile APIs, for example, right? That'll make it clear to understand. So for designing a pizza API, right, let's decide what resources need to be available. Um, Assign URLs to those resources, decide what actions they need to perform, and what is a different kind of data that's required to perform an action. So from a design perspective, right, I need to understand to place an order, what are all the things that I need to have in order to make this whole ordering of a pizza viable, okay? So I'm going to go a little faster in the interest of time. So in terms of assigning URLs, right, there's a standard REST API best practices that you need to follow in order to do this work. So whenever I say pizza.com, pizzahut.com/orders, right, that's basically a list of all the orders that exist in the system today. And if you want to basically figure out one particular order information, I will place it as a variable. So if you created an order, and if you order number is 1234, right? This dollar variable / order ID will be basically your particular order. Okay. So if we go to, if the REST API is exposed, and if I'm calling a get method on orders, I would see all the orders in the system. If I want my particular order, I want to interact with only my particular order, I will be going to orders. And if my order number is 1234, it will be like, slash orders slash 1234 that I will pass in to find out details about my particular order. So that URL, this is how you would design your URL in order to accomplish what you need to do. Okay. So what we call as endpoints, this is one particular endpoint. Um, this is another particular endpoint. And these are the standards you would basically use. So in this case, if you want to list all the existing orders, you will do slash orders. If you want to retrieve a specific order, you want to update your order, you want to cancel your order, I need to access my order first. And I would do it via slash order ID. Okay. So if you look at, the get method, it'll be slash orders, which is list of all the orders. If you want to create order, it'll be a posting to orders that will place a new order. Get is, if your order is number 1, my order is number 2, we will interact and get it by orders for 1 and 2, etc. Like you get update an order will be /1, delete an order will be order /1. And your HTTP verb or the method distinguishes the different kinds of actions you want to perform. Okay, so you're basically using a HTTP, you're using the URL to accomplish a function, you're using the method to do what you ultimately want to do. Okay, and when I'm doing, like, for example, creating an order, what is the order that I want to create? You have to send that information through the body, right? So for example, you'll say thin crust, thin, toppings, onions, tomatoes, etc. Right? And when you send it to the service provider, they will send back a response. And the response will be like 201 created, and you will be assigned a ID called 5. So in this case, this is the URI. URI is part of the URL. This is your body, right? And this is your response header, and this is your response body. Okay. So this is how you would go and design your API to be a meaningful exchange via HTTP using inherent HTTP URL, methods, body, and headers. Okay, at a very, very high level. Now I send back a 201, which is basically created. A 200 would indicate that it's complete. It's basically a complete. It's successful. But in this case, right, we just received an order, and then we're going to be processing. It's not like the order is complete immediately upon request, right? So that's why I send them back a 201. So there's meaning to the different numbers, to the response code that you send back to the caller. Okay, and why that is very, very important is many of the systems there's no human interaction. Those are system to system, right? For Uber Eats will basically interact with your Pizza Hut APIs, right? And when Uber Eats sends a request and you send back a 201, it knows that that particular order has been created, and it's being worked upon. Okay, but if you send back a 200, Uber Eats will think, okay, this order is complete. Now I can tell the consumer, hey, go and pick up your pizza, which is completely wrong, right? So there's a huge distinction between, and all these things are automated between two systems. And that's why when you design it, you have to make the design really, really clear so that all this automation across these two systems are very meaningful, fully automated, and there's no confusion. If there's a programmer that instead of 201, they said 200, right? It can lead to it's a very simple distinction, right? But it could have led to a lot of confusion because Uber Eats would have just sent to all the consumers, hey, your order is ready, as soon as they place the order. And that can lead to a variety of confusion, as you guys can understand. Okay, so it's very simplistic, but how you design things is very important, and how you use things is very, very important from a design perspective. Okay. And ultimately, right, say, for example, they want to update a particular order, and my order is order number 5. I created my, I changed my mind. I want to use a different crust, right? Then I would do a put method. See, from a user perspective, I'm just going to tell Uber Eats, hey, change mine to deep dish. Uber Eats app will understand that and then create a REST API call to Pizza Hut's REST API, and call this particular /Pizza Hut /orders for that particular customer, whatever that customer order is, and then pass this particular body, right? So if you look at it, they may not pass a full all that information, only what information change for the update that will be sent. And for that particular response, this guy might respond with a 200, which means I understand and completed that particular request for that, which is an update. For that update, I'm sending you, yes, that particular update is completed. That's it. This is all the 200 means. It doesn't mean your pizza was created, which is a different order, okay, which is for the post method. That's a different call. For that, I have to send back a 201 because I just accepted your order in that particular case. In this case, I did an update. I want to say, hey, your update is complete. And that's why I'm sending back a 200 in this particular case. So there's meaning behind this response code, and it's very important to follow the standards. If there's an exercise we want to create, customer and order. Let's see if we can go through it quickly in the interest of time. So as you can see, right, if you want to update your order, you would use something like this. Again, if you look at the structure, right, I'm sorry, I skipped over a little bit. This is not XML. This is what is very, everybody probably knows. It's called JSON. So JSON is basically, it's ubiquitous and very popular these days because it's very easy to understand. The structure is quite simple. It's basically key value pairs, right? My crust and a thin. And for toppings, I want multiple toppings, onions, tomatoes, mushrooms, whatever. So I want to send multiple items. Then I would send in the means of an array. So the square brackets represents an array. So key value pairs and arrays at a very simplistic level, JSON format would look something like that. You can also have nested JSONs where there can be further nesting along the line. Okay, so you can have nested elements within each other, and they can have arrays and or single elements, etc., etc. But if you look at it, it's very readable. It's very simple to understand, and there's no overhead of tags that XML uses. So the amount of data going across the wire is actually very small. So there's two functions. One is the usability, readability perspective, and the other is the technical perspective, the amount of size and the bytes going. So because of those technical reasons and because of the usability and the user experience reasons, JSON has become extremely popular, and it has become the standard for REST APIs. And that's why you would see it everywhere. Okay. Now, if I want us as a system implementer, right? We saw CRUD operation: create, read, update, and delete. Now, if I want to see how many as a service provider, right? I want to see, hey, I want to see which of the toppings are getting used in the pizzas, which are the toppings I'm not using, right? And basically, if I'm getting tomatoes, onions, and mushrooms, and people are not ordering onions at all, on my supply chain as a service provider, right? I want to cut down all the onions, and I'm not going to serve that as a service anymore. I'm just going to offer onions, tomatoes and mushrooms going forward because nobody's ordering any onions typically, right? So I can save some cost by cutting off all the my onion supply chain, right? So how do I find that out? In my system has all this information. So for a data analytics person, right, I will expose an API where they can search on all the toppings. And how do I do it via REST API? So I would say, pizzahut.com/orders, and then tell them where topping equals mushroom. Similar to a SQL query, right? Select star from whatever, where customer name equals whatever, or topping equals mushroom. That where clause basically becomes your, in the REST standard, what is called a query string. Okay, so this part makes up your query string. So I'm querying on my orders and telling the criteria over here. Tell me all the topping with mushroom topping. Tell me all topping equals onion, topping equals green pepper, whatever. And if I find that one particular onions is extremely low, then as a service provider, then I would just cut off that particular topic itself, right? So there's value in in understanding information as a service provider, and you provide all those functions. One is serving the consumer. In this case, via query string, I'm serving the data analyst of my particular company for doing all his queries. And all this can be accomplished via REST APIs. And this particular mechanism is called a query string. Okay. People get confused between query string and query parameter. A lot of developers even today. The query parameters and query string are literally the same. When you define it, there's a definition and there's runtime, right? When you define it as an API in your API design, you define this as your query parameter. Your parameter is topping, your parameter is crust type, and the value is mushroom or crust type equals thin, thick, etc. And when it grows across the wire in your URL, right, it grows across as a query string. So query parameter is the definition side. The query string is the runtime when it grows across the wire. Okay, and that's what I told over here. And as you can see, you can have multiple query parameters. I can say, give me all the orders where the topping is pepperoni and crust equals thin. And by different permutation and combination of orders, I can find out what is the most popular kind of pizza that I'm serving up as a service provider. What is the least popular pizza that I'm serving? And based on that, I might make some adjustments to focus on the better selling pizzas and focus less on the least selling pizzas. So there's value in doing that. And you can do all that work via APIs. Again, this is just an example of REST APIs that Instagram provides, and you can go and play with that, like same examples with Twitter. So I would advise you guys to go and get yourself familiar with it to understand what are APIs, how are they doing their APIs, how are they exposing their endpoints in a meaningful manner, and then when you create your own system, we'll follow, you'll have a better understanding at that particular point. I've already exceeded by 4 minutes, so I will stop for any questions at this point. Anybody have any questions?
Sai, you got more slides, or this is the last one?
This is it, yeah.
Oh, okay. All right. So we are almost on time, almost.
Sorry, I had to rush a little bit at the end.
So there are 3 people or do not have, or I don't know how to make them to give a mic access. So Abdul, Srini, and Sri Suman something. So if you guys want to have a question, you can chat, put it on the chat. I hope the chat appears for you too. Yeah, so it looks like everyone got a mic access now. So if anyone has a question, so you can unmute yourself and ask.
Sai, this is Muthu. It was a very good presentation. Thank you for doing this. In one of the slides, you mentioned that we can go to that regress.in to play around and practice. So I'm guessing you can use curl or a postman to try that out.
Oh, the example URL, something ending with a .in.
Correct. Yeah. Correct. Yes. Because with the browser, right, you can only send a GET request. You cannot send POST request and other ones, right? So you need some kind of client software to do this work. Postman is the most popular one that everybody uses to do that.
Okay, got it. Yeah. Okay. So, and one other question I have, I don't have a pure development background per se. So, but I am trying to get my coordinates. So the tools like, AWS has API gateway and things like that, right? So, you mentioned MuleSoft and Perigi, I guess, or
RPG, yeah.
RPG,
yeah.
Not Perigi. So they provide similar functionality. Let's say they provide a platform where you can.
Exactly. See, there's all these companies, right? Basically, they want to make money end of the day, right? So different companies. So how do you make money? You want to expose what you have as a service, right? If you think about like a car company, like a auto shop, right? You have a board there, right? If you go to the board, it'll say oil change $35, whatever, different services that they provide, right? So as a software company, if I want to make VR software, I'm going to expose all my information via my developer portal, right? If you're a healthcare and I'm a healthcare provider, right, I will provide you a list of services that I have. And you, as a subscriber, you can come and choose, I want this service, this service, this service. I will pay you this much money to use your services. So I'm going to expose on my developer portal a list of my services as REST APIs.
So they will, for example, taking that example, car service service, right? So maybe, if Walmart providing a car service, if I want to schedule an appointment to do an oil change through my phone, and I want to use MuleSoft, Walmart would work with MuleSoft to make sure the APIs are made available through MuleSoft, and the app would automatically use the MuleSoft to connect to the endpoints. I'm just trying to
right. Understand the whole picture. What so for what we'll do in the particular case, right? MuleSoft is a company, right? So MuleSoft has what is called an anypoint platform, which is there, but everybody calls it MuleSoft, right? Which is okay, right? With the anypoint platform will help you create, maintain, and manage your APIs. So for Walmart, in this particular case, they want an appointment, right? So I will go to MuleSoft. I will set up the MuleSoft platform. I will create a set of APIs. The noun will be like Walmart.com car service / appointment.
Sure.
Okay. And then I will create the get, put, all these functionalities. And this REST APIs will expose to different, possibly different. One is your own Walmart app, internal. Okay. And that internal app, mobile app, right? Mobile app will be a separate team, right? And you are a service app where you take this information and then you go right to a database, right? You read from a database, etc. For example, right? That will be the service side. The mobile app, think of it like a front end. Sure. Okay, they are just concentrating on making it very beautiful with Flutter or whatever app they use, right? The user experience is what they mostly concentrate on. They'll take that order from the consumer. The consumer will install the app on their side, and they will just send the information. The mobile app will call this APIs on the backend, right? And this APIs has to be hosted somewhere, right? So you'll have an API gateway. First, it'll hit an API gateway. MuleSoft has its own API gateway, okay? And if it's on the API gateway, we'll have, for example, policies, right? Typical, just like any other gateway. So the policy is, hey, this particular user wants to access the API. Is an authorized user? No, he's not authorized. Then I won't let him in. If he's authorized, I will let him in. And then it will go to the interface of the API and the implementation, right? Which is all running on MuleSoft. Okay. And from MuleSoft, I can even go to other APIs if necessary. From MuleSoft, that API, I want to see, is this user within 5 miles of something? Then within that implementation, I might call an external API to Google API, for example. Does that make sense?
Yeah. Okay.
Yeah. So all those API implementation and the API hosting and the API, the policies, all that stuff together make up the API platform. Okay. And there's also analytics. For example, right? This particular user called this particular API 100,000 times in one day, right? That kind of information, there's an analytics dashboard to see that kind of information. There's a security dashboard. There's management, and then the actual running, which is the runtime. Okay, these are all different. Once I get to another class, I can just show all that work.
Sure. Okay, got it.
Yeah.
Thank you. Appreciate it.
Yeah, no worries.
Any other questions? Okay. Sai, this was excellent session, Sai, today. I really enjoyed it, and I know a little bit of the REST API, even though I'm from networking operations side, but we used to use REST API in some of our own development side. But this is really useful, and thank you very much for today. And if anyone has a question, somebody posting it, okay, just a message for appreciation. And if there is no further questions, so we can conclude. The sessions are already recorded. Aru will help to post this in the YouTube channel later on, and you can watch it later or share with your friends. And so there is a group also, WhatsApp group. It's so if anyone or your friends want to join this group, because it's just a community service, it's a free service. You can ask them to join here, so they'll get notified. And also, if you have to if you want to present something, you can also do that. Sai was just joined a couple of weeks, and he was listening when Muthu was presenting, and then he interested to present today on the API side. So anything on the technical side you want to present, you can do this. It not necessarily have to be the AWS, but any technical that will be useful for other people, you can tell us and tell the group or Aru, so we'll schedule it. Okay, thank you very much, and have everyone nice day.
Thank you. Thanks.
Thank you all.
I just posted the, in case if somebody is interested in joining the WhatsApp group, I just posted the URL there. So please pick it up.
Okay, I'll close the meeting now.
Thank you, Kanag.
Yeah.
Thank you. Yeah.